This over here is the fastest 8-core CPU in the world, the Ryzen 7 7700X. But as a creator, is that fastest 8-core CPU enough to beat the competition roughly at the same price point? If you're wondering how does this compare to the Intel's equivalent processors as a creator, then this is the right video you are watching.
Looking for a cheap way to license your Windows? Check out WhoKeys through the links in the video description. Make sure to use the code TN20 to get a 30% off. Paste the license to the activation settings and you're all done. This license is for Windows 10, but you can upgrade it to Windows 11 for free. They also offer Microsoft Office 19 license. Use the same code TN20 to get a 30% off. Check out WhoKeys.com in the video description below.
So jokes aside, this CPU is actually quite expensive. It costs $400, and I want to say big thanks to CCL Computers who actually provided me with this CPU, in fact all of the 7000 Ryzen CPUs, to provide this helpful content to you. So if you're based in the UK, I highly recommend checking out CCL online and their PC part stock, their pre-built PCs, their laptops, all sorts of PC gear and tech gear. Very competitive prices. In fact, very often I've found that their prices are the cheapest compared to the competition, so worth checking them out. I'll leave a link in the description below. So when we're paying $400 for a CPU, I want to know if I've made the right choice as a creator. We've got 8 cores, they're the fastest cores, the fastest 8-core CPU in the world. But now the Intel's competition actually on the other side offers a lot more cores for the same price or even a bit of a cheaper price. So I chose 4 CPUs that fit in the same kind of price range type of thing. So if your budget is roughly around $400 or something like that for the CPU, then you'd probably be looking at the 7700X, this one over here. The 13600K was actually the cheapest in the lot over here, which only cost $330. So about $70 cheaper. Then we're gonna add in the mix the previous generation Ryzen 9 5900X, which cost around $350, which is the lowest I've seen it on Newegg. So that's gone quite low not right now. And then we're also gonna be adding the i7 12700K from Intel in the mix, which cost roughly around $356. Now this $400 part from AMD is the most expensive in this price range, but if we go a bit further up and look for something that's closer to this price range like Intel's 13700K, which is roughly about $450, the performance you're gonna get for that is quite a bit more. And I think once you can afford $400, then the 13700K is like a different price range, and it actually competes with the Ryzen 9 5900X. So if you're looking for the mid-range kind of, play area, then we have got the i7s from previous generation and then this over here. In terms of the core counts, this is the lowest one in the mix of CPUs here, but it's got the fastest max turbo frequency at 5.4 gigahertz. The other interesting thing here is the max turbo power that we can see drawn from the CPU 100% utilized in an application like Cinebench R23. We can see that this 7700X actually pulls the least without PBO enabled. We can see roughly around 120 watts being pulled, which just means that we don't have to spend as much cooling to keep this CPU cooled. It does have an iGPU as well as some of the Intel counterparts, and it's got a 5nm node, as you can see on the spec sheet on the screen, compared to the Intel, which has 10nm. So it's almost like they can fit twice the amount of transistors in the same amount of space, but it's not exactly apples to apples comparison, because one of the actual chip manufacturers is TSMC for AMD, and Intel makes its own chips, and they kind of say that Intel's 10nm is equivalent to AMD's or TSMC's 7nm, so they're not quite apples to apples comparison. If we are looking at the price point here now, and what I wanted to do is see the CPU price difference, and you can see that the 7700X is the most expensive in here, but the other part is the actual platform cost, because the Ryzen X 670 and 670E platform is quite an expensive part. We thought that Intel's 12th gen is expensive, and maybe said 790 is expensive, but the X670E is the most expensive part over here. So what I wanted to do is take as a creator, like a creator motherboard lineup, and then see how much do these cost in the equivalent chipsets. So for the 7000 Ryzen, we have the X670E ProArt Asus motherboard, which costs $500. In the Z690 chipset version for the 12th gen and 13th gen, it costs $450, so there's $50 cheaper, and you can probably get it even cheaper. I highly recommend checking out the latest pricing in the description below if you want to check them out. But then we've got the 5900X Ryzen 5000 series, which uses the X570 chipset, but because that motherboard or that platform is pretty much EOL, then the motherboard prices for those are very, very expensive, which makes the platform adoption for the 5000 series Ryzen very, very expensive. And I would recommend you to upgrade to 5000 Ryzen if you're maybe in the previous generation of something, just because for the money you get much more and much better bang for buck if you go newer like Ryzen 7000 or Intel 12th or 13th gen, because they just offer much more performance and specs for the same amount of money. And then we've got the 12700K from previous generation that kind of slots in the middle there. So if we're looking at the price difference, then the 13600K is about 10% cheaper, the platform cost. The actual CPU cost is more than 10% cheaper. The 5900X is about 5% more expensive, or $60 more expensive than the 7700X. And the 12700K is about 7.7% cheaper compared to 7700X in the overall platform cost. So if the 7700X performs better than 10% compared to the 13600K, then it's better value for your money. If the 5900X performs 5% better than the 7700X, then it's good value for money. And if the 7700X performs more than 7.7% faster than the 12700K, it then kind of makes sense just because of the price difference. So these are the numbers that we need to keep in mind when looking at the benchmarks results here, to really see where does this make sense, and where does the price to performance kind of slot into. Another very important thing here as well with the comparison of the CPUs is the memory controller. And the memory controller in the 7000 Ryzen CPUs isn't as impressive as on the 13th and 12th gen, because when you have two sticks enabled, single rank and dual rank, then the 7700X in Gear 1 supports up to 5200 MTs compared to the 5600 MTs on the 13th gen and 4800 MTs on the 12th gen. MTs meaning mega transfers per second. When we've got four sticks, whether single rank or dual rank, the 7700X or Ryzen 7000 series supports 3600 MTs, which is actually quite a bit slower compared to the 13th and 12th gen, which supports 4000 MTs. Now, this is something that the manufacturers don't really show on the website, and I had to really dig it out from the Intel's side of things. AMD does the same thing. Not all of the specification on the AMD website is actually shown there as well, with the four sticks XMP basically, or four sticks, speeds. So basically what this means to you is if you're trying to run XMP or just faster memory with four sticks, it's not going to work as well with the Ryzen 7000 series compared to the Intel's 13th gen and in fact even 12th gen, just because of the memory controller is better at four sticks to support that. So if you want to get more than 64 gigabytes of RAM right now as a creator, then the Ryzen 7000 series CPUs, they're really going to just be slower than DDR4 basically, which is just ridiculous. The 13th gen right now offers 4000 mega transfers per second, but if you want to go DDR4 and save even more and just want the large capacity of RAM, then the 13th gen and 12th gen are the ones to go, because they support DDR4 as well, which is just ridiculous. But if you want just two sticks and want to run really fast memory, maybe like 6000 or 6400 or 7000, something like that, then it might not work with the Ryzen 7000 series, but the Intel 13th gen will be more likely to support that, just because the memory controller is so much better. It's basically just a very complicated topic because of the DDR5 and the new platform. And DDR5 is so much more scalable than any of the previous generations of RAM. If you want to see an ultimate DDR5 and XMP kind of tutorial, then let me know in the comment section below. I've got a very interesting idea about that. Then looking at the power consumption, and here we're just looking at the maximum power consumption when the CPU is 100% utilized in a not very kind of a natural workflow, which is Cinebench R23. Now, if you do Blender cycles or something like that, or render in a V-Ray or something like that, then you will see these numbers. But if you're using it for photo or video editing, you'll pretty much never see these numbers, just so you know. But the 7700X pulls about 120 watts. The 3600K pulls 148 watts, which is more than that. And the 12700K pulls around 163 watts. And the 5900X pulls 132 watts. The 7700X actually pulls the least amount of power here. I'm also working on a very comprehensive power consumption video where I'm actually measuring power consumption over a workload rather than full utilization, because that's more workflow like. So hit that subscribe button to do that. I just have loads of data to gather and make statistics of that before I can actually present that to you, but just so you know, that's coming. First of all, Cinebench R23, which shows us the single core and multi-core performance of the CPU. In single core performance, the 7700X is a very fast CPU and the fastest in the bunch over here. The 13600K is 0.2% slower, which is basically neck to neck. They're exactly the same. The 12700K is 0.7% slower. It is slightly slower. You're not gonna notice that, but in the actual numbers, it is slower. The 5900X is 17% slower, which is quite an impressive leap over the previous generation for the 7700X. In terms of the multi-core speeds, the 7700X isn't as impressive here. As you can see, the 13600K, the i5, which is cheaper, performs 23, almost 24% faster. The 12700K is 18% faster, and even the 5900X is 10% faster. Moving on to Geekbench 5, we can see that the single core performance is very, very impressive in this benchmark. And it looks like the faster gigahertz in the single core performance here does make the difference. The 13600K is about 9.3% slower, the 12700K 11%, and the 5900X about 20% slower. In the multi-core score though, the 13600K is 24% faster, the i7 12700K is 15% faster, and the 5900X about 5% faster. But now the real applications for creators, and first we have Blender. In the Blender cycles here, usually previously AMD offered a much better performance because we had more cores as an AMD, and usually Intel couldn't really keep up with the Blender, kind of benchmarks. But now here, the i5 13600K is 15% faster in the monster scene, 17 and 12% faster in the junk shop and classroom scenes respectively. The 12700K is 4.7% faster in the monster scene, 1% faster in the junk shop scene, and 5% faster in the classroom scene. And even the 5900X is 8% faster and 13% faster and 7% faster in the monster, junk shop and classroom scenes. So the tables have turned. AMD isn't the best in terms of Blender performance anymore at this price range. We can get so much more performance out of the Intel side, which is on this side, Intel side of things. But then let's have a look at photo editing and Adobe Photoshop. Here, interestingly, those fast cores from the Ryzen 7700X are really, really fast and very, very impressive. The 13600K is about 2.5% slower in the overall score. The 12700K is about 4.2% slower, and the 5900X is about 20% slower, which is quite a big leap in terms of generational improvement. And bear in mind, the 5900X has 4 more cores compared to the 7700X, but the single core performance really makes a difference here in the Photoshop, and Photoshop loves, fast cores. I do want to make another point here, which is the 12th gen, the 12700K, has still a little bit of an older benchmark result for me, just because I haven't been able to update this. I only have one GPU to swap it between the Testbench. So the 12700K has 4800 megatransfers per second XMP compared to the 5200 megatransfers per second on the other CPUs, which is the 7000 Ryzen and Intel's 13th gen. But the difference isn't that big, and there might be a few % difference there. And I will be updating that in the future videos, but just for this video, you know that the 12700K has a few % performance still kind of in the pocket just because of the faster RAM speeds. But in most of the cases, what I have updated so far, honestly, the difference is within the margin of error, and it doesn't make that big of a difference, maybe only a tiny little bit. But just so you know. In Lightroom Classic, the 13600K now here is about 6% faster overall score. The The 12700K is about 14% slower in the overall score, 5% faster in the active score, which is very, very interesting, just because the active score usually is very much related to the single core performance, and the faster the single core is, the better it is. But even though the 7700X has a faster single core performance, it's still not faster in the active score in terms of working with your photos, and gains most of the lead in the actual passive score, which is just fascinating that the more cores you have, like on the 12700K, is not actually as good here for Lightroom. Now the 12700K is 16% slower in the overall score, but interestingly the active score is very much neck to neck. Just an interesting analysis here. But the 5900X is about 20% slower in the overall score. So the 7700X here really shows a very, very good performance. But then at the same time, the 13600K here makes much more sense. In terms of video editing performance here now and Adobe Premiere Pro, we can see that the 7700X really isn't impressive at all. The 13600K is 34% better in the overall score. Standard overall score is 40% better, 41% better. The live playback scores are up to 110% better, which is just ridiculous. And the 12700K is the similar story, 38% better and 41% better. It's ridiculous, ridiculous performance. The 5900X here is only slightly better, but still loses at the standard live playback score and effect score slightly. So if you're using Adobe Premiere Pro for video editing, it's not really as impressive as the Intel side of the competition. In Adobe After Effects, we see a similar story. The 13600K is about 5% faster in the overall score. Multi-core score is about 15% faster. That's due to the large core count, obviously, on the 13600K. The 12700K is 0.8% faster in the overall score, and the 5900X is about 12% slower in the overall score. Moving on to DaVinci Resolve, and here, very importantly, I want to mention that the 12700K and 5900X use a little bit of an older version of DaVinci Resolve, which is 17.4.4 compared to the 18.0.4 that we're using on the 13th gen and the Ryzen 7000. And in my experience, the DaVinci Resolve 18 is slightly faster in the benchmarks than the 17, just so you know. So the i7 and the 5900X have a little bit of performance on the table here as well, but not massively to make a huge difference. But then interestingly here, the 7700X absolutely loves to use DaVinci Resolve. Here, in terms of 4K media, 8K media, the 7700X is much better pick. And the Ryzen processors here for DaVinci Resolve in this benchmark look much, much better. The 13600K is about 7.9% slower. The 12700K is about 22% slower, which is ridiculous. And the 5900X is about 25% slower. If we're looking at the fusion score, then the 13600K is only 0.2% faster, which is just interesting. But here, that's where you see the huge difference. The 13th gen and the 12th gen, the fusion score is what makes the huge difference here in terms of the CPUs. And that's what I've usually seen with the Resolve 18 and 17 version. By the way, this is DaVinci Resolve Studio, not the free version. But I do want to mention another thing, which is the playback or time playback speed on the timeline. Usually DaVinci Resolve is very good at doing that anyway, and if you're using 1080p timeline or maybe 4K as well, you're not going to see the difference. But if you're using H.264 or H.265 codecs, then the Intel iGPU, the UHD 770 there, is a much better pick there for you, just because you can actually use the hardware acceleration to play that back. And lastly, V-Ray. 13600K is 13% faster, 12700K is 10% faster, and the 5900X is about 15% faster. So as you can see, the tables very much have turned here for AMD. AMD used to be the one that has more core counts and offers better multi-core performance, but then slightly, slacks back on the single core performance. But honestly, look at this, the tables have completely turned. AMD has lesser cores and faster cores, which basically results very good performance in the photo editing applications and not so good performance in the 3D applications and in video editing applications. If you do use DaVinci Resolve, I think the Ryzen 7000 or the 7700X is fine, but then at the same time, the iGPU for the H.264 and 5 codecs does make a huge difference for the Intel 13th and 12th gen, so just bear that in mind. And this is like the middle ground of the CPUs, creeping quite close to the high end of CPUs, and the CPU cost is $400. And here's where I have a little bit of a problem with this 7700X. To me, at this price point, this CPU doesn't make any sense unless you're really banking on the future upgradability and want to get like more than two generations out of this one, which we can expect from AMD. AMD hasn't really confirmed that, but this is most likely what's going to happen with the 7000 series Ryzen CPUs or AM5 socket. But to me, that CPU needs to cost around $300 in order to really be appealing and saying, come on, buy the 7700X right now for creators. Because most of you, if you're not a photographer, just go with Intel's 13th or 12th gen, whichever one, you know, your budget allows to use there. But if you do use it for photo editing solely, then basically this 7700X is a very, very good pick. If you have mixed workflows, I'd say the Intel one still is a little bit better, just because the 7700X isn't that much better in the photo editing applications. As you can see, we only gain about 3 to 4% in the Photoshop applications, and in Lightroom Classic, the 13th gen is actually faster, and the 12th gen is about 16% slower. So it's a little bit hard to recommend the 7700X, as you can see there. Now, it might have made sense when it came out over the 12th gen because it was faster, and when you're doing gaming, you know, it's a different thing, but here we're looking purely at creators' perspective. It just needs to be cheaper in order to make sense. $300, yeah, then we're making sense. And the 7600X, if you haven't seen that review, go check that out, needs to be around $200. Then it will make sense because we're competing at the right price points here. So purely for a creator's perspective, it's hard to recommend the AMD over Intel just because of the price you're paying and for the performance you're getting. But that's due to the pricing at the point of when I'm making this video. I have heard some rumors that AMD is going to drop the pricing, so before you judge and actually go with the other, you know, generation of CPUs or pick this Intel over the AMD, highly recommend checking out the latest pricing in the description below. You can click on the link and then pick your favorite shop and check out the pricing in there, just so you're up to date with what the latest pricing is, and it might change by the time you're watching this video. But what I'm happy to see is the fast cores from AMD, which is very, very good. We haven't seen that from AMD before. And the actual power draw at maximum utilization, which is only 120 watts, which just means that you can get away with half decent air cooler, so you don't need to have a ridiculous cooler to actually cool this down, which is nice to see. Now, if you do want to see a certain CPU comparison from the 13th gen or 12th gen, let me know which CPU pair would you like to see in the description below. Pick 2 GPUs and let me know this in the comment section below, and the most popular one, I'll probably make those videos. If you're looking for a best bang for buck PC build for creators, then check out the Create a PC Build guide in the description below. There's a 4-part video series, and you can pick a PC that will fit your budget. Pick the one that's closest to your price point, and then you can configure it to fit your needs, to fit your budget, to get the best performance possible for your budget. I highly recommend you check them out in the description below. Thanks guys for watching, and I'll see you in the next one. Bye bye.